I want to spend a little bit of time distinguishing energy and power. And the reason I want to do this is because it's so confused often, these two different quantities that have related but different units that are related to each other, but they're not the same. Energy represents the total amount of something. Joules, it could be how quickly something's moving. The faster it's moving, it means the more kinetic energy it has. Or it could represent the energy associated with a system of objects or a system of materials. You have chemical energy stored in a battery or even in your body. That's a system, and there's the relative positions of the molecules dictate how many calories or joules actually are within your body. And you can get into all sorts of biochemistry in talking about that. But the idea is that it's an amount of energy associated with something. It's a total amount. That's energy. And potential energy is energy associated with position. So if you have two objects more separated from each other that are attracted to each other, then the further separated they are, the more potential energy there is, because the harder they're going to hit when they come together. So you can think about energy as being kinetic or potential energy for now. Heat is also the transfer of energy, but that's at the molecular level. So just think kinetic and potential energy for now to kind of give you that impression of what energy is. Units of energy could be calories. Didn't write that in, but calories are a unit of energy, either big C or big C calories or small c calories. I'll write them both in there. A big C calorie is actually 1,000 small c calories. And a big C calorie is the calories that are in your food. So when you say a muffin is 200 calories, that means calories with a big C. Means there are 1,000. That means there's 200,000 little c calories, and each of those little c calories could heat up 1 gram of water by a degree centigrade. So there's a lot of energy wrapped up in the food we eat. It's hard to imagine that you could heat up that much water with a muffin, but you could, in theory. Another unit of energy is a joule, and there are about, I think, 4.17 joules in a calorie. That's the conversion. So they're similar in size, relatively. Calorie is a little bit bigger than joule. But a joule will actually be able to lift an object that has a mass of, see if I get this right, an object that has a weight of 1 Newton, which has a mass of about 1/10 of a kilogram. It can lift that 1 meter off the ground. That's how much a joule of energy can do. Seems like a lot, but a calorie is bigger. In any case, that's energy. And of course, you can put the prefixes on them. You can call them kilojoules, megajoules, kilocalories, megacalories. Those are all units of energy. Those are just bigger, so they represent more energy. Another unit of energy that will make more sense in a moment is the watt-hour. The unit of power, as I'm going to say in a moment, is the watt. If you multiply that times time, you're back to energy. So you have the watt-hour, you have the kilowatt-hour, you have the megawatt-hour. Those are all units of energy. It's an amount of that stuff that makes things work. Power, on the other hand, is not an amount of stuff, but it's how quickly that amount of stuff is changing. You can think about it that way. So power represents how fast the energy is changing, maybe added to or taken away from something. And the basic unit, the SI unit for power is the watt, which is a joule per second. So the watt, you can also have the kilowatt, you can also have the megawatt. You can put all the prefixes in front of watts that you want. I just give you some of the more common ones there. Another unit of energy that a unit of power that you might see is a kilowatt hour per day. You may say, why is that? How does that power? Because a kilowatt hour is a unit of energy. I say that above. And it's a unit of energy because it's a power times a time. And remember, power is energy divided by time. So if you take that power and you multiply it by time, you get energy back. So this kilowatt hour per day, well, let's think about it. A kilowatt hour is a unit of energy. Divided by day, that's a unit of time, and you're back to power. Similarly, you could have watt hours per day, megawatt hours per day. You could have megawatt hours per hour, but then you're just back to megawatts, not very interesting. So these are all units of power. All right, so that represents a rate of change. And why am I emphasizing this so much? I'll give you an example of something that's misused often. You might see something written in the paper or written somewhere else, and it sounds impressive. You might say, this power plant, I've seen this many times, generates, let's say, 100 megawatts per day. Okay, megawatts per day, what are they talking about? It's none of these. It's not energy, it's not power. It sounds impressive because a megawatt's a big amount of power, but you can't have power per day. That's not what the author was intending to say. Maybe they were intending to say megawatt hours per day. Maybe they were just intending to say megawatts, because a megawatt is a unit of power. And you can say this power plant is rated at 10 megawatts. That means when it's really pumping things out, it can pump 10 megajoules of energy out per second. That's what's called the rating of the generating system, is how much it can generate at most, how much power it can generate. And so that is often confused with energy, and I'm really hoping that this little blurb that I gave you will help you to distinguish between energy and power. A power plant can be rated in 10 megawatts, can be rated as in 5,000 megawatts per day. Those are all units of power. That's reasonable. It's telling you how much energy it can produce in a given amount of time. That makes sense for power, and that's how you're going to rate a power plant. All right.